Good evening. I'm Liz Smith, Event Director at Expona, and I'm pleased to welcome you to tonight's webinar, The Ultimate Digital Audio Source, presented by Andrew Gillis of Small Green Computer. So first, some housekeeping notes. Tonight's webinar will last about an hour. Andrew will start with a short presentation and then take some questions. So if you have some questions, please submit them via the question feature that you'll see in Zoom, and we will answer as many as possible at the end of the presentation. So now a little bit about Andrew. Andrew is the owner and CEO of Small Green Computer. Andrew has been in the audio business for more than 20 years and got his start in the voice over IP market. Andrew has been building and selling music servers for more than a decade. Some accomplishments over his career include the introduction of one of the first music servers for Squeezebox and developing the first Roon-ready network player streamer. His company, Small Green Computer, is dedicated to utilizing the latest technology to bring your entire music collection to life. So with that, Andrew, are you ready? Thank you so much for being here tonight. Are you ready to get started?
Yeah, I am, Liz, thanks. So I can go right in here. So we're going to go over this a little bit. We got a little history of digital audio and understanding your options, optimizing your digital audio source, and question and answer. So digital audio. So of course, originally we had analog audio, things like record players, tapes, all those different types of thing, and then they invented the CD player. And so the greatest thing about it is digital audio, assuming that the media doesn't get destroyed, lasts forever, right? You have ones and zeros, you can store the same track on multiple bits of media, and it will never get altered or lost like analog media can get scratched or damaged. So that's the advantage. Now the disadvantage is it needs to be converted back to analog at some point so you can listen to it, and that part, there's all sorts of different things that can go wrong. And so you want a good source. A digital source is very important. If you don't have a good one, you're not gonna get the best sound. So this is the original setup here with a CD player. The CD player has a digital to analog converter, converts to the CDs back into analog, goes into an amplifier, out to speakers. Sounds great, except for you always have to dig through your CD collection to find the CD you want, and the CDs can get scratched or you can lose them, etc. So the first thing that people did to try and get past the CD player was to use a computer as a digital source. So this is, you take a CD, you extract the data from it, you have it in a file on your laptop, and maybe you run a USB cable to a DAC, which this was just a component, and then you feed the analog from that into your amplifier. And that worked pretty good, except for now you have to sit next to your stereo system with your laptop, or have a really long USB cable or something like that, and you have to have the laptop in your lap. Not the greatest solution. So the next thing that came along was sort of streaming. There's Tidal, there's Qobuz, Spotify, all of these different types of things. So you have an internet router in your house, you have a tablet or something like that, and then maybe you have some network connected speakers or Bluetooth speakers, and you can send the streaming to that. The problem was you lost your original music collection, everything you had on CDs. Maybe you had some tracks you really liked, they're hard to find, couldn't play those anymore. Also, if your tablet went out of range of the Wi-Fi or had a spotty signal, it would break up. You get a call on your phone, and you start hearing the thing ringing out your speakers. Not the greatest solution, but you did have access to lots of different tracks on these streaming services. So then the next step was people really started to develop good software for listening to music. Now, when you had a CD player, you didn't need any software. You just dropped the CD in, and you press play. That's it. Now, these software packages do a lot of things for you. They index all of your music. They allow you to create playlists, of tracks that you like. They allow you to, get information about all of the different artists and the track and when it was made. You can listen to different versions of the same track. And there's quite a few different pieces of software, out there involved. I personally like Roon. As Liz said, I was the first person to make a Roon ready network player. Roon really kind of came after a lot of these other types of services, and they really tried to do everything. They tried to have a good app, a good way to store local music, a good way to play streaming music, and a good way to kind of integrate it all into one sort of unified, easy to use system. But, Roon's not required. There was DLNA. I mean, that was a collaboration between a lot of different companies. In theory, anything that supports DLNA is interoperable. So there's a lot of different pieces of software and servers and players. And then I've also got the streaming services on here. I put Tidal and Qobuz on here. There's a lot of other streaming services, but I picked those two because they, at least at the moment, are the only ones that have really good CD quality music. There's some other, services that are starting to come in with that, but they're either locked in very proprietary systems that can only be used with certain hardware, different things like that. Qobuz, Tidal, very interoperable, very high quality tracks, basically as good as CD or better. So that's what we're talking about here. So over here on the side here, I'm kind of showing your home network, right? So this is a router. Pretty much everybody has the internet now in their home. They have a router from any, a cable modem, a fiber modem, any of these types of different services. I like to put an Ethernet switch in this picture. Sometimes the Ethernet switch is in the router. I just put it here so you can see it. Either way is fine. And then you have a control device. This can be a phone, a tablet, something like that. And then you have a music server. I used our Sonic Transporter i5. That's where you would have your hard drive where you store your music files. And that's where sort of the core of your music system runs. If you're using Roon, that's where the Roon core runs. So now I'm going to go over here to the and kind of go over all of these different components. So here, we have this network that we talked about. And by the way, you can see that I'm using wired Ethernet. I'm a big fan of not using wireless. We found that wireless works well sometimes, but then it doesn't work well sometimes, right? If there can be various types of interference, even just like your refrigerator running, your electric dryer running can create radio interference. If you have a wired Ethernet cable, you're going to be able to listen to music. You're not going to get dropouts. It's going to sound great, and so that's what we recommend, and that's what we're showing here. So you can see I have a music server, and then I have a music player. Back in the first slide, we were connecting our laptop directly to our DAC, with USB. That's not great. You get noise over the USB cable from the laptop to the DAC. And this is analog noise. This is noise from all the switching power supplies and the processors and RAM that are inside your computer. And they, a cable is just an antenna, or it allows the digital signal to travel, but it also allows analog noise to travel. So here in this system, we've actually split it up. We have the music server, and then we have a streamer, which has linear supplies, very, very clean. And it's separated by Ethernet, which isn't completely immune to noise, but it's a pretty good way to keep everything separated and not allow the noise from the server into the DAC. So that's what we got here. USB still to the DAC. There's other ways to connect to DAC. There's SPDIF, which was the older way to do it. There is also I2S, which there's no standard for, so that's kind of all over the place. USB is still probably one of the best interoperable systems between a network player and a DAC. So the next thing I want to talk about a little bit about is building a network using fiber optic. And so So why we do that is, again, we're trying to eliminate noise, getting into your system. That's the point of what we're trying to do here, right? We're trying to get music converted back into analog without adding any noise to it. And so, yeah, you want a good DAC that doesn't create a lot of noise inside itself, but you also don't want to add any extra noise into the DAC. And so what we're doing here is we're the music's still coming in from the router, the streaming comes in from the router, your local music is still stored on the server, but we're using fiber optic cable to connect the Ethernet switch to the streamer. Now this fiber optic, this is not some proprietary system that we came up with. It's just Ethernet over a different media. Ethernet can obviously go over wireless. It can go over a wired cable, and it can also go over fiber optics. This sort of stuff was originally invented for sending Ethernet very long distances, but it works great for short distances because noise can't travel over a fiber optic cable. So here our Ethernet switch doesn't have a fiber optic port on it. It just has regular Ethernet. So we're using this little simple media converter to convert from wired Ethernet to fiber optic. We're using a streamer that has an optical input, and then we're going over USB to the DAC. So it's pretty similar to the last picture, except for we're using the optical to filter out all of the noise from the network. I've seen some audiophiles go to some pretty extreme things to try and eliminate noise in their system. Obviously, everybody wants a low noise floor. That's what's going to sound really good. So they're putting linear supplies on their Ethernet switches, putting linear supplies on their routers, and all those things do work. I mean, any noise that you can get out of the system is not going to make it into your DAC. The biggest advantage of this is you're cleaning it all up with this last little piece of optical cable. So now it doesn't matter as much what's going on, on the kind of on the left side of the page here. And so basically, it's almost like I have the left side here with the router, the Ethernet switch, and the media converter, and the music server, and then I have the right side with the streamer and the DAC, and the fiber optic is kind of connecting the two. And one is kind of like the clean side, and then the one with the Ethernet switch is the dirty side. And so that's anything that's happening on the dirty side is being filtered out. So you're getting a pretty good system here. And just keep in mind, this DAC I have here is just kind of a generic picture. I mean, when you're trying to make the ultimate digital source, the DAC is very important. You want a good one. There's a lot of different DAC manufacturers. I think that's one of the most common pieces. There's probably hundreds of different people that make DACs. And so, yeah, you gotta read reviews. If you can do an in-home trial for 30 days, listen to the DAC. Some of the filtering that they do, some of the other different things they do to convert the digital to the analog is going to make them sound different. A lot of them have different features. Some of them support DSD, some don't. Some can play various levels of high-res music. So yeah, shop around, get a good one. You get one with multiple inputs if you want to try a different one, but typically, at least at this time, USB is going to be a good one. So this is another thing I wanted to bring up here, and this is a DAC with a direct Ethernet connection. So a few years ago, nobody'd ever heard of anything like this, and now we're starting to see a lot of these in the industry. And so what this is a DAC that basically has a streamer built into it. So if you look at the back, maybe it still has USB, maybe it still has SPDIF, but it also has an Ethernet port. And you connect this via Ethernet, and now you don't need a streamer. You need your music server. You still need your network, and you still want to control it all with a tablet, but you can play directly to it. Now, some of these also have their own software. They have their own apps you can run, so you don't need Roon, you don't need DLNA. You can run an app that's made by the DAC manufacturer. That's somewhat limiting. Most of those you can only, they only support certain things. They're certainly not as robust as Roon. They don't have as many features, but it's something you get with the DAC, and it's you kind of staying in the ecosystem from that manufacturer. So if you like that, that certainly works. The advantage of this is you are getting some level of isolation with Ethernet. Ethernet is galvanically isolated, not that much noise travels over it. So this is usually a pretty good setup. Of course, who knows how good these streamers are, right? This little streamer built into your DAC has to convert the data back to I2S or something and send it down to the DAC chip. And how much noise is added at that point, again, is based on how good that that streamer is. So that's something you'd have to check with reviews and research. One thing you can do, is isolate the DAC. So before, we isolated it by using a fiber optic player. This one, we're going to take out that Ethernet connection, and we're going to add in a fiber immediate converter. Now, we're using a high quality one. I have seen people, online, they've just used a simple $20 fiber media converter you can buy on Amazon, and they're like, wow, it sounds better. If you use, a media converter that's actually meant for audiophile equipment, it's going to sound even better than that. So the setup I have here, and again, I've taken the other media converter out of the picture. You can see there's a fiber optic cable here, so you still have to either have something in your switch, you either have to have an optical port on your switch, or you have to have another fiber media converter to convert to optical so that you can convert back. So you think all these conversions back and forth are going to potentially add noise? Well, they don't. The only time where noise can be added is the last little wired Ethernet connection between the media converter and the DAC. So you're going to eliminate all the noise from sort of everything on the left-hand side of the screen, and then potentially you're going to add it back in. Use a short Ethernet cable, pretty well shielded. This is going to be a big improvement. So here we are. We went from one box to a whole bunch of other pieces. Is complexity better? Well, I don't know. After you've watched all this, maybe you're like, boy, I sure wish I just had my CD player and I could drop in a CD and just listen to it. But you're really gaining a lot of stuff over here. Pretty much the mid-level of any of these types of a good DAC and a good streamer, a good music server are really going to sound much, much better than a CD player. A CD player, it has to read the bits off the CD in real time. It's going to lose some of them, even if you got multiple lasers. It's never going to sound as good as using a music server and a proper DAC and in a network like this. And it's definitely, you're not going to be able to have playlists or, all of these, all of this other stuff. So yeah, you added a bunch more pieces over here, but you're definitely coming up with much better sound when you're done. And this does matter. I see people all the time that are like, well, I have the greatest DAC in the world. I have the greatest amplifier in the world. I don't really care what I feed into my DAC because it's going to clean it all up. You can't clean up something perfectly that's already dirty. If you start off with clean sound, you're going to get clean sound, and if you start off with dirty sound, you're going to get dirty sound that's cleaned up to sound good. And I mean that's a big difference. So after I go over all this stuff, and I work with a lot of people to sort of help them set these systems up. They're like, wait, so what do I have to do to sort of get one of these things? So this little list I've just put together here, this is like, sort of a shopping list that's going to get you a great system. Now, are there other ways to do this? Of course. I mean, there's tons of other equipment. Every piece of equipment on this list you could use something else. I'm just showing you on this list something that will work and will sound amazing, right? I've got a 4-port switch with a fiber converter. This is a very, very good switch. I've listened to a lot of other ones. This one definitely sounds the best. It's it doesn't cause any problems. Like you'll never get dropouts with this switch. I've seen other ones, they're slower, you know, they're not designed as well. You can get dropouts, you can have problems. Are there better switches than this? Maybe. Are there ones as good as this? Sure, there's tons of switches that are as good as this. I just put this on the list because it's a good one. SGC music server, there's lots of other music servers. This is a very good one. The optical Rendu with a linear power supply. And again, the player, the part that you connect to your DAC, you really want to, you know, that's where all the like magic's happening, right? Because that's where you're creating the sound, it's going into your DAC, and that's where you have the potential to add noise. And so, you know, if you use a good player, if you use a linear power supply, you know, if you use a good power conditioner, you know, this is where you're going to get a really good digital source. The last thing here is a USB cable. If you go online, there are literally thousands of posts talking about whether cables matter. Someone's like, hey, I bought a $5 cable at Walmart. It works great. My system sounds amazing. Someone else is like, hey, I had to pay $20,000 for a cable for it to sound good. The answer, as with most things, is you know, is somewhere in between. You do need good cables. You probably don't need to spend hundreds of thousands of dollars on them, but you definitely don't want the Walmart one either. So I picked this in acoustic cable that we sell. It's a very, very good one. But basically they're just using zero oxygen copper, very low resistance, triple shielded. You're not going to get a lot of noise. I mean, that's kind of what you're looking for. So questions. That was a pretty good 20 minutes. So what questions does anybody have? Let me open my my chat window here so I can see what people got. So the first question we have is, I only have a limited number of ports on my power conditioner. What should I plug into it? Now I get this question all the time, because if you look at this list, you know, I've added a whole bunch of different pieces. There's a whole bunch of different pieces of equipment in these pictures I have, right? There's a router, there's a music server, a switch. You know, how many of these things you need to plug in your power conditioner? And the answer is just one thing. Well, really two: the DAC, which you probably have already, and the streamer. Anything on the other side of that last Ethernet cable, or that, or, you know, even better, the last fiber connection that's sort of on the dirty side there, the noise from that is not going to get into your system. So if it's just plugged right into the wall and you're getting, you know, some noise from your mains, that's not going to affect it. And that's one, because that's one thing I don't show in any of my diagrams, is sort of where to plug in all these things. And so you know, how to power them all. And so that's a question I get a lot. So let's go down and see what else we have on here. Right. Someone says don't confuse optical Ethernet with optical SPDIF. I do get that question. You know, that's why I actually show the CD player with the SPDIF in here. You know, that was, I mean, we're talking, you know, 30, 40 years ago. Someone was like, how can we get digital audio, you know, into something without you know, screwing it up, and they came up with optical cable. It's funny how we've gone sort of around the circle to all these other things, but SPDIF and optical Ethernet are very different things. And someone says, I don't understand how using fiber eliminates noise. Well, so a wire is basically will pass all signals, right? So you know, if you're sending over voltage levels that represent, you know, the ones are and zeros that are the data, but then any other type of signal will travel over that. Fiber optic, it's just light. It's a light transceiver. There's no way for other light to get into the fiber, because it's, you know, it's surrounded by plastic. And so the only thing that comes out the other end is the data. There's absolutely no noise. And this really is interesting, right? Because you very rarely have a chance to 100% eliminate a noise source. I mean, people are like, hey, if I can get, you know, 120 dB down of eliminating some noise source, that's great. But fiber optic really does, you know, eliminate all of it. Let's see what else we got here. Let's see. So this one, it just has this question I got is what's the best optical converter? And what about SFP modules? So yeah, I didn't really go into that a lot. I did another presentation about a month ago on networking for audiophiles, where I talk a little bit more about the networking side of this. You obviously do need a good network for this all to work. I've played around with some different network, SFP modules. They don't seem to make that much of a difference. There are certainly better ones you can get. The SFP module is actually where the laser is. That's the thing that's converting the electrical signal to light. And so of course on the other end, that's where it gets converted back. But if you power the SFP with a linear supply, which is what we do in the Sonori products, it's pretty clean, and that seems to be true of a lot of different SFP modules. This question also asks, what's the best optical converter? Yeah, I recommend the Sonori optical module. I mean, that's the best one we've seen. There certainly are other companies that make this kind of stuff. But again, that's what you use on the clean side, right? On the dirty side, when you're converting from Ethernet to the fiber, that's your chance to use your one that's just built into your switch or something like that, because that's definitely not as important. Well, any other questions we have? That's I'm going back over the panelist thing here. I don't know what else we got. Liz, we got any other questions as people want to answer?
Just give me a second. I'm just looking for the report.
Well, here there's a little question here about SPDIF and I2S. I can talk about that a little bit. Yeah, so someone else still asked another question about SPDIF and I2S and USB. Yeah, I mean, these are there's also AES EBU. So these are all ways to get the digital data into your DAC, and there's really four, right? There's USB, SPDIF, I2S, AES-EBU. AES-EBU and SPDIF are very similar ones, just differential. I mean, man, you go into each one of those and why each one is good and bad. USB is good because it's really widely used, and it's very, very reliable. SPDIF was good because it was sort of the original digital connection, but you get, it's only single direction, so you don't get a lot of feedback if there's some kind of a problem on the far end. And also it has kind of a lot of jitter because the clock and the signal are sent together. I2S is actually how DACs usually communicate internally, so it was designed for very short distance. People have used amplifiers to allow it to go over longer distance. In many DACs, that is the best input. The problem with it is there's no standard. So every DAC has a different connector. So it's very tricky to connect one thing to another with I2S, just because you never know what the pinout of the cables are. AES-EBU is the third one that this panelists didn't ask about, and that's just SPDIF, but it's sent over differential. So differential is another older way to eliminate a lot of noise. And so yeah, AES-EBU is good. With most of our equipment, we stick with USB because pretty much every DAC has that. It works really well, and it supports a lot of different rates. And there's a lot of good cables out there that keep it pretty clean.
Andrew?
Yeah.
Question came up about differentiating the optical rendo from the signature, the Sonori signature. Can you talk a little bit about that?
Yeah, I mean, now we're just kind of getting into some stuff about our products, and that's this is actually a Sonori product that we helped to develop. But there's the optical rendo and then the signature rendo. And so the optical rendo is more of a mass-produced product. It has very good clocks, very good linear supplies. It has a very, very clean USB output. But then the signature Rendu is, I mean, it's a signature piece. It's actually built one at a time by an engineer who spends a lot of time actually tuning it and really, listening to it while he's working on it. It's almost like, paying someone extra to custom tune, a Ferrari or something like that. And it really does have, better sound because it's really tuned. But that's the kind of the top level. All right. Well, I mean, if nobody has any more questions, I think that's probably pretty good. We'll get done a little early tonight. I don't know.
Hold on. There's a couple in the chat that are not in the question and answer. Just going through them. Give me a second.
Okay.
Can you talk a little bit more in detail about the dirty side and the clean side? There's a couple people who are asking that question.
Sure. I mean, basically, the fiber optic is converting your Ethernet from electrical signals to light signals, and then it's being converted back on the other side. So that's where all the noise is being eliminated during the conversion from from one side to the other. So pretty much anything on the sort of, in my pictures, it's on the left side, the side where the converter to optical is the dirty side, and then everything on the right side, where it's being converted back is the clean side. In some of our pictures, we're using an optical Rendu, which actually has an optical Ethernet interface. So then it's actually converted back inside the player, which is the best place. But the whole point is anything on the dirty side, all of that noise is gone. So pretty much, you don't need a particularly good converter over there, and you don't have to worry about putting linear supplies in. You don't have to worry about using good shielded Ethernet cables, because your Ethernet cables are going to pick up noise, but then it's going to be stripped off, by the converter. And again, we're talking about analog noise here. It can be a little confusing because I've heard people say, because there's a lot of discussion about using optical to clean up Ethernet in the forums, and I see sometimes someone will pop in and say, well, you can't clean your digital bits, they're not dirty, you can't like wash them off, and that is exactly true. Ethernet is a very reliable mechanism. If data is lost, there's checksums, it can be retransmitted. So the digital music getting from the server to your DAC, no bits are lost, right there. It always makes it all the way through. The problem is how much analog noise comes in on that wire, and that's what we're working to eliminate here. We're using fiber, so we get the digital data, but we don't get any of the analog noise.
Can you talk a little bit about the type of SFP module, and specifically is it an LC or an SC SFP module?
So fiber optics were developed for the communication industry, and they were sort of designed to do medium distance, sort of like between two buildings, maybe over like the distance of 1 kilometer, and also very long distances where they're going across the country. So there's multi-mode fiber, there's single mode fiber, like the participant just said. There's LC, there's and it's not quite the same as Ethernet, right? Like wired Ethernet, there's only one connector. So you get in, there's Cat 5, there's Cat 6, there's Cat 7, and each one of those is just a little more shielded than the previous one, but they're all interoperable. You can plug one into the other. The fiber is not like that. You have to have a transmitter and a receiver that are using the same frequency of light, that are compatible with each other. We just came up with using the LC and using the OM1 fiber and that specific light. We did that because we tried it, we listened to it, it sounded great, and we decided to just standardize on one thing. Can you use other ones? Sure. That's actually why a lot of products have these SFP modules, because you can pull a module out and you can put in a module that's a different frequency of light that supports a different connector, and that way you can use the optical gear with different types of cables and frequencies and all this kinds of stuff. It's definitely a little more complicated than Ethernet. So by standardizing on one thing, we just tried to make it simpler for everybody.
Another question came up about why not directly attach your music server to your DAC using fiber optics?
That's a great idea. And so in order to do that, you would need a network DAC, so a DAC that already had a streamer in it. And then in there, you would need, an optical connector. I think the very high end, like the $12,000 Lumen DAC actually has that. That's the only DAC I've ever seen that has an optical Ethernet connector. Maybe in the future, all DACs will have, optical Ethernet, and it'll be easier to do this sort of thing. But for now, most DACs are USB, and so yeah, we use a player, and we still have to go to USB.
Okay, just as a follow-up to that, one of the customers mentioned the Sonic Transporter i9 with the optical output.
Yeah, so we sell an i9 server, and it has an optical Ethernet port and a regular wired Ethernet port. The advantage of that is you can go right from the server to the player, or from the server to the DAC. If you using an optical module, if you have an Ethernet DAC, that's mostly for convenience. Does it sound any better? Not necessarily, but it certainly can, because it's there's less equipment involved, right? It's every time you add different pieces of equipment, you have the potential to mess something up if you do it wrong. I mean, if you buy stuff that's all designed to work together, that's probably not going to happen. But mostly that is just for convenience, and it's nothing like having a direct connection. It's going to work.
Question about Rune Ready. When in our diagrams, was the i5 or was the Rendu the Rune Ready player?
So in the Rune architecture, you have three things, right? You have a Rune core server, and you only ever need one of those, right? That's the core of Rune. That's where the Rune database is. That's where all your sort of music lives, and that's the center of Rune. And then you can have one or many Rune Ready players. And so, yeah, in our diagram, the Sonic Transporter i5 is the Rune core server, and the Rendu is the Rune Ready player that you connect to the DAC to make it into a Rune Ready DAC.
Okay, we've got some specific questions in here that are. I think we'll just have to reach out to these folks individually. They're talking about their systems, very specific questions.
Yeah, there's another one about let's see. Oh, this question says, does it matter if your computer server has a switching power supply or a linear power supply? And that's a good question. As long as you have fiber optic cable, it doesn't. So I had a lot of different slides in this, and there was definitely ones where I was talking about just a direct Ethernet connection. I mean, a lot of things in the world are still Ethernet, and there's certainly a chance that you have a server and it's connected to a player with just an Ethernet cable. In that case, using a linear power supply on your server is going to improve your sound. If you have optical, it's probably not, because all the noise is going to get filtered out. So again, all of these things help. It's just a matter of which ones you use, and if you use one piece, then you don't need the other ones.
You had mentioned that I2S has a limited cable range. Do you know what the maximum acceptable distance is?
No. So back to what I was saying about I2S before, the original I2S standard was developed to only travel a few inches. So it was supposed to be between the decoder chip and the DAC chip on the board inside the DAC itself. So, you'd have like a USB chip. It would take the digital data coming in over USB, it would convert it to I2S, and then it would go to the DAC. And that happened in usually less than an inch inside the DAC. And, then someone had the great idea, let's run this cable outside so that, we can feed I2S into a DAC, but from a remote piece of equipment. There is no standard for this. Every DAC manufacturer did their own way of doing it. They use their own pinout, and so it's also the amount of distance you can have is different depending on the DACs. They're using some types of amplifiers and buffers to take the range of this signal and increase it from a few inches to potentially a few feet. But at the end of the day, shorter is definitely better. I mean, that's true of most digital interconnects, but it's definitely true of I2S. The shorter the better.
Question about if you've got a room-ready DAC, and with a built-in streamer, what's the benefit of having a Rendu?
There isn't one. You don't need one. A Rendu is a streamer, and so yeah, if you already have one inside your DAC, yeah, you don't need a Rendu. Yeah, a Rendu is for USB DACs, or if you have a SPDIF DAC, you can use it with a converter to go to SPDIF.
Do you see manufacturers adopting Thunderbolt to help with reducing noise?
So Thunderbolt, there's a lot of different protocols that can travel over Thunderbolt, and it's pretty complicated. Manufacturers just got around to figuring out USB and adding that to their DACs. They were running SPDIF for years, and now they're finally like, well, we can add USB, and then some are adding network ports. I don't see them adding Thunderbolt. The entire Thunderbolt spec is actually rolled into USB 3, so you'd be more likely to see a USB 3 DAC than you would a Thunderbolt DAC.
So in our recommended system, how does that compare in terms of audio quality versus, say, like the much higher, more expensive Arianders, Arialics, Lumens, etc.? And I mean, the person who asked the question says it's a subjective question, but they just
it's a very subjective question. So if you take something like an Ariander, that's all in one box. Well, so you have the advantage of you just sort of buy this box and set it on the table. And it's got a DAC built, so that is everything in it, right? It's got a server built into it, it's got a player built into it, it's got a DAC. I mean, this is what they call an all-in-one, right? Some of them I've seen even have amplifiers in them. You can connect them directly to your speakers, so they're really taking out everything in the entire chain and sort of putting it in one box. That has some advantages in that all those pieces can be made to work together. It has some disadvantages in that you're kind of stuck with all those pieces and you can't change them. Ariander doesn't support Roon. You're stuck using their proprietary app. I would always go with a more open solution where you can replace different individual pieces, but there is certainly something to be said for an all-in-one solution.
Another question: one customer one participant in our webinar wants to educate their audiophile friends about the benefits of getting rid of their computer, their laptop, and basically replacing it with a music server and player, but doesn't really know how to start that conversation. What do you recommend?
Hey, just get one at your house and have them come over and listen to it. And when they go, wow, this sounds really great and it seems so easy, then you can bring it up.
We do also offer a whole bunch of videos at smallgreencomputer.com that kind of cover a lot of the basics. Our first webinar on networking also talks a lot about it. So we're happy to share those as well.
We have a YouTube channel, a lot of good stuff.
All right, so that it for questions? All right, well then, a huge thank you to Andrew for taking the time to share your knowledge tonight and answer everyone's questions. I know we all really appreciate it. To learn more about Small Green Computer, visit smallgreencomputer.com. You can also send your questions to them. And thank you to everyone for watching. We have more webinars scheduled this month, so keep an eye out for announcements. And we look forward to seeing everyone in person later this year at Expona, taking place October 29th through 31st. Have a great night, everyone. Take care.
Great. Thank you.
Thank you.
Bye.
Yep. Bye, everybody.